All right. All right. Well, welcome everybody. I guess most people are um, hopefully coming back from our little short break. So we are going to kick off this data jamboree, which I'm really excited about. I think this idea is brilliant to try to tackle kind of the same problem, but in different languages. This is, I think, hopefully will be really exciting from a pedagogical perspective, and as also just to sort of learn how these different languages work, especially coming from people who are experts in them. So this is wonderful. So I think we've got three folks here who are going to be each tackling this problem in each of their respective languages. We have Josh Day, who will be doing it in Julia. We have Dan Chen, who will be doing it in Python. And then we have Sam Tyner, who's going to be working in R. So this is very, very exciting to be able to have all three. So let's see. So the first, let's see, kicking off, I think, Josh, is that right? Are you going first, or did we switch the order?
I'm happy to. I thought I saw an email that Dan
Yeah,
was
that
going to
Dan
go.
was going to go first. Yeah, I was looking at the schedule online and I think we had, but I think we switched the order because Dan maybe has a conflict. So, yes, so Dan is going to kick us off here. So, let me just do a brief intro for Dan. Dan Chen is a postdoctoral research and teaching fellow at the University of British Columbia. Dan is going to be tackling this problem in Python. And Dan did his PhD at Virginia Tech in genetics, bioinformatics, and computational biology, studying data science education in the medical and biomedical sciences, and also is the author of Pandas for Everyone. So thank you so much for doing this, Dan. We're excited. And let me just say, if anyone has questions, feel free to post those, and I'll try to get them to the speakers as kind of as I can. And I think because Dan is we were gonna kind of hold some of the questions for the very end, but because Dan's gonna need to go, if you have questions in particular on that section, feel free to post those, and we'll try to get those in before the conflict ensues. So, all right. Well, with that being said, you go ahead and take it away, Dan.
All right, hello. So hopefully you see a screen. Um, all right, cool.
We do.
Uh,
Yes.
okay, so first I would like to acknowledge that where I am currently in Vancouver, Canada, that I am on the traditional, ancestral, and unceded territory of the Musqueam people. Another part of I guess, my background is I also work for Posit, formerly known as RStudio, as a data science educator, and I work on like their Python side of stuff. So it's also kind of weird people calling me an expert because Python is such a big language that I don't know every part of the language, which you will see, and I will fully admit today. All right, so we're going to go through a couple of exercises, questions around a data set that was posted by the New York Open Data folks. And we'll sort of go through a couple of questions and see how the data manipulation and some of the analysis stuff that we can do. I've alluded to the fact that Python is a really big language. There is a saying in the Python world that um, Python is the second best language for everything. So there are a lot of things that I'm not good in Python because I actually just use another language to do some of those things. And primarily that is some of the stat stuff and plotting. I almost always go into the R language for it. So that's where that's coming from. There was something a bit amusing that I think I like lost the actual tweet. Okay, so this actually just happened a couple of days ago, sorry, a couple of minutes ago or hours ago, where Trey Hunter asked this question: "What is the most common Python typo?" And for me, it's actually using the wrong assignment operator. So I really do bounce around between R and Python quite frequently, and so. Even a tool like Cordo that Dr. Bates has alluded to is actually a really good tool for me in that I can literally, in a single analysis, just bounce between two languages. All right, but so the questions. There's a couple of questions that me, Sam, and uh, Doug is sorry, Josh is going to present, And essentially, we're going to go through a lot of exploratory work with this particular data set. So you don't have to worry about each of these questions as presented, although I have striked out some of the parts that I'm not really going to be talking about. There's a total of 9 overall topics. I'm really only going to talk about 8 of them, and then we'll sort of go through these questions as they come up. So, all right, so part 1, the actual data. There is a data set that exists on GitHub, and you can actually load this library called pandas, and pandas is the data frame library in Python. So unlike some languages where data frame, like R, where the data frame is like part of the language at the very beginning, there is a package that you have to install and load to work with tabular data in Python. But there is this handy function called read CSV, and you can load tabular data like the one that we're going to work with into Python. And so you can see like this is the data that we're working with. There are some categorical variables or some numeric variables, et cetera, et cetera. So the first thing, if you look at the first set of columns, there's a lot of capitalization here, and there's like spaces. And when you're sort of programming with data, one of the most common things is the making typos, especially cases and stuff being inconsistent with one another. So just like another programming language that we'll talk about later today, there is a library called Janitor, and one of the most frequently used functions in that package is called clean names. And then what you get is a consistently formatted set of columns. So I don't have to worry about capitalizations. I don't have to worry about what is the character use is split between words. It just makes things a little bit easier. And then let's take a look at this particular data set. It has about 7,659 entries or rows in our data. There are 29 columns. Python is a language that starts counting from 0. So that is that's a thing that you have to be very mindful of. And then if you scroll down and you look down this particular column, you'll see that not every single value in this data has a value in it. So there are missing values that we have to think about. And you'll see that even like some of them only have like very, very few values. So for example, like vehicle type code 5, I guess that's kind of seems like in a particular accident in New York City, a vehicular accident in New York City, was there a 5th car involved? And I guess that's a good thing that there aren't that many 5 multi-car accidents in our particular data set. All right, so the first question that I'm going to ask, or I was asked to figure out how to do, is create a frequency table with the number of crashes by borough. And so what we can do is we can select the borough column straight out of pandas, and then there is this method called value counts. And what I like to do also is, even if I know that the data doesn't have missing values, I always just habitually give me a count. I want to see missing as a 0. And so that's a habit that I have, that I do. And especially in this data set, there are missing values. So if you don't actually tell it to count missing, you'll actually not even get this report in your data set. So I always make it a habit that give me the count for missing, even if it's a 0, because I want to explicitly see it. And you can see here that there are a lot of missing reports for this data, and that sort of makes me wonder why this isn't reported. So that does end up being something to investigate. Like, why is this missing? Is it part of some bigger problem, or is it like missing by random? And that's something that we do have to think about when we start doing and start exploring our data. So question 2 is create an hour variable with integer values from 0 is supposed to say 24. And so what I can do is there is this column called crash time. And the thing about Python, when you compare to other languages, I'm going to compare to R because that's what I use the most, is if you're coding your data analysis in Python, you actually have to think more like base R syntax versus like the very integrated tidyverse set of syntaxes. So here we have our crash time. This is the notation to treat that column as a string. And then the string does have a method called split. And so because the time is reported as like hour colon minutes, I can say, just give me split by the colon and then give me the first component of it, and that'll give me the hour. Now, I'm doing this set of analysis as if like I'm doing my first pass because it's literally the first pass doing it. What I should have actually done is actually take this time and turn it to a date timestamp and then extract the hour component out of it. That'll give me a little bit more of a robust type of reading for like reading in this particular column, because then I can potentially catch improper times input into this data. Because right now, I could have easily put in a value called 24, and there's no 24th hour, and it would still come in correctly. But once I get that first column out, or that first component out of my column, I can assign it to a column called hour, and then reassign that back to my data frame. And just looking at the two columns, you can see that it's roughly doing the proper thing. And so from there, we can plot it. And so we can use a package called plot9 in Python, which is essentially a ggplot2 port in R. And that makes me very happy because I can just copy paste things from one side to the other and don't have to learn something new. But if we look at our ggplot, one thing that you'll notice at the bottom is it's sorted, but it's not really sorted like the way I expect it to be sorted, right? So it's like going from 0, 1, 10, 11, 12, because it's actually doing it, sorting it as a string. So we should go fix that, right? And so what we can do is Pandas does have a function called toNumeric, and it'll turn anything that you pass it into a number, and then we can assign that back into our data frame. And so what I ended up doing is I created a new column. So there's the hour column that is a string, and then now our int, which is now a numeric value. And so now we can replot the histogram, literally the same piece of code from earlier, but I'm using a different column. And voila, I have a properly set of like sorted figure for this. And if we look at this, it does kind of make sense, right? Like if we look at the number of observations going on or reports of things going on in this particular data set, there's fewer incidents in the super early hours of the day. So this is in New York City. So this is 5 o'clock New York City time. So that makes sense. And it does follow like this rush hour cadence of, as more people are doing something, you're going to have more incidents of something. All right, so question 3, check if the number of persons killed is actually equal to these other columns, and just treat that number of persons killed as the actual answer that we're going to work with. So there is this method of just looking at the columns, because this does have a lot of columns in our data. So we can actually say, from this particular data frame, just show me all of the columns, and these are all of the columns in my particular data set. And so what we are really interested in are these columns that end in killed, and then we're trying to see if this value here is actually equal to all of the other counts in the other columns. So first thing that I want to do is I'll just select the columns that I am interested in to confirm this calculation. And there's a reason why I'm doing it this way, because when I subset this data, all of my values is one type. They're all numbers. And so that becomes important, because the next thing that I can do is I can apply the function sum. So I want to sum a bunch of values in this data set. And I want to do it axis equals 1, which means I want to do it across each row. And the other reason why I ended up subsetting all of my data set before, so it's all a number, is this is something you want to be a little bit careful of when you're in Pandas, because if you end up doing it on your original data set, each column is going to potentially have a different type. And you do end up with a performance hit if you start mixing types going across an axis, because it does have to convert everything into a single the same data type. And then from there, we can use the same value counts that I did before and see that we do have values where there are people who have been killed in this particular accident. And then we can compare it to the number of persons killed, and it's really off by 1. Don't exactly know why, but we are going to stick with this particular value for now. So question number 4, construct a crosstab table for the number of persons killed. So pandas does conveniently give us a function called crosstab. There's another way you can do this as a group by operation, and I believe Sam does it in her the way she does it. I just picked crosstab because the question asked for crosstab, and I used it that way. And so we can actually create a crosstab. What I'm going to do is also give me the row and column sums at the same time. And then there's some stuff that ends up happening in Pandas world. Just for a little bit of background, Pandas was written by Wes McKinley when he was at a hedge fund. And so a lot of Pandas was built for the need of what the hedge fund needed, which is a lot of time series stuff. And what are the other implications of that is Pandas has built in what's known as like a hierarchical index. So your rows and columns can be put together in a hierarchy. And that's not something that most people think of when they think of tabular data. So it's somewhat of a more domain specific way to think about your data. I know economists who particularly like using Stata because it does have support for hierarchical columns. And that's sort of like something similar in the pandas world as well. And so occasionally you will see some code to sort of flatten or get rid of the hierarchy. And so that's sometimes sort of the wonkiness that you have to deal with when you're working in pandas. There are other data frame libraries in Python that are coming out. So for example, there's IBIS and polars that completely get rid of the hierarchy nature of it. And so those are just more emerging tools that you can look into if you're trying to think about doing data analysis from Python. And so here is our crosstab. So we have for a particular reason, whether or not a person died or not, and then the actual row sum. And then if I had the ability to scroll all the way to the bottom, you'll get the column sum as well. So there's a bunch of accidents, but not every accident leads to a fatality, which is a good thing. And so the other thing that we want to do is collapse the contributing factors with a count of less than 100 to other, right? So if we go back to our crosstab, there's a lot of scenarios where, like, for example, like animals being involved in a accident isn't really has a really low count. And so that it could potentially affect our analysis as well if we try to create a predictive model because the count is so low. So it's probably a good idea to start batching and grouping things into an other category. And so the way I do this is I write a function in Python. It takes 2 values. One is the type, and then the other is the count. And all it's doing is if the count is less than 100, return other. Otherwise, just give me the actual factor that I passed in back again. And there's this little bit of notation that I do. And this is because at the end of the day, I want to pass in 2 columns of values into this particular function, not just individual single things. So you can think of this if you know of like a programming language like R, like the per library that you can map of values into a function. This is sort of a analogous way you can do it. And so with this function called recode factors, I can say recode factors and pass in the column that represents the contributing factors and then the columns that have all of the counts. And this is what I get back as an entire vector. So some of them become other, some of them become alcohol involvement, and then there's another other value, et cetera, et cetera. And what I can do is then take that result and create another column called recode. And we get another recode column. So now other, because it has a value less than 10, 100, the accelerator defective is now all being binned together. And then again, we can do another count for all of this. So 27 of the categories have been collapsed into one. So just like what Dr. Bates said, like you want to trust that your analysis work, but you also want to kind of write some code to verify it. And so this is sort of like my thought process of like, I just did something. Can I also write code to verify that it worked? Next is creating a renaming dictionary. So we have two columns of values, and I want to create this dictionary because I want to be able to recode my data set. And so we do end up with this pair of values that we can use to recode. And then what we end up doing, is using that dictionary to actually go and recode our original data set. So now the question is there any association between these things? And if we look at our crosstab, I want to say that the association is probably something we don't want to look at because there's so many zero counts. And so even if you try to do like a chi-square is definitely not the right way to do it. I don't even think a Fisher exact is the right way to do it because there are literally just zeros, so many zeros in the deaths column of our data. All right, so question number 5, create a new variable called death, which it just turns it into a binary column. So very similar to before, I create a column. If it's greater than 1, return a value. Otherwise, return 0, and apply that to a data set. Apply that to our data set. And again, we've also reconfirmed that like, hey, there's 18 observations where someone has died, and a lot of other where it was just a motor vehicle accident. And so now can we cross-tab it against boroughs? And you can see that there are, accidents across different boroughs. I want to say probably fewer things in Manhattan because it's so dense and people try not to drive in Manhattan. That's just sort of my personal experience of living there. But so that is sort of one of the things that I've noticed looking at this particular data set and using some domain, just living in the city. Question 6. So visualize the crashes. I am really bad at making maps in Python. Even in R, I'm pretty bad at it. So I essentially threw my hands in the air, and I usually use Python for a lot of data processing and not for mapping things. And so this is part of my punting of Python is the second best language for a lot of things, for everything. And I'm going to punt that question. The next question is fitting a logistic regression model. And this is something that ends up being really important. So you can use this library called stats models, which if you are a statistician, this is probably what you mainly think about when you're the way it gets implemented is how you think about it as a statistician. And it has a really similar interface if you're used to R with this formula notation. And let's say we're trying to fit a logistic regression predicting death based off of the hours and the categorical value borough. And so we can get, statistical output like we're used to seeing. We can also get a set of parameters, coefficients, and you can interpret those log odds as needed. But I do want to also mention that there is another library called scikit-learn that is very popular in the machine learning world. And this is sort of how you would create a scikit-learn model, where you import the model, you create the actual model, and then you put in, there's multiple ways of doing it, but you have to manually create your dummy variables. There are somewhat semi-automated ways of doing that, but that's one of the differences between using scikit-learn and stats models. But then we can put in our predictors, put in our response variables, and get our coefficients back. So one thing I do want to point out is if we look at our results from stats models and our results from scikit-learn, scikit-learn also is missing one because it's not showing the intercept. Those numbers are different. And those numbers are different because in scikit-learn, because it's coming from the machine learning world, if you look at the linear model logistic regression documentation, you'll notice that there is this parameter here called penalty equals L2. And that literally says that by default, there is an L2 penalty happening in logistic regression. And it actually says it in the documentation that regularization is on by default. So that is something probably extremely terrifying for you as a statistician when you are trying to do logistic regression and it is regularizing without you knowing. So I say that because whenever you go and use a function, don't just copy and paste and use functions that you find from the internet. At least look at the documentation, especially since we're here and this is a statistics group. Even if you don't understand like bits, like the every single technical bit of this, you should be able to pick up on some things using the domain knowledge that you have. And so, like especially this part, that should be ringing a bunch of bells at you. But there is a way to turn it off. You can say penalty equals none. There's other differences between why the models are different, but that is one of the big differences between really popular machine learning libraries in Python and like statistical stats libraries in Python. The next thing is, well, we fit this machine learning model. Like, is this even like a good model to fit? So if we like look at this, like, I think one of the coefficients ended up being like, I think the hour coefficient ended up like having statistical relevance to it. But is that something I really want to think about or uh, like attribute to? It's like probably no. This is probably not a really good model to be fitting to begin with because there's only 17 values. Of interest that we care about, and it's probably this like one uptick is like driving everything from what I'm understanding. So again, like we can fit a statistical model, doesn't mean it's correct, and it's probably, and it could potentially not even be doing what we are thinking it's doing. And the last set of things is we can do things by zip code. Zip code got treated as a number. We can see that there are 5,000 zip code entries. If we look at this, some of the zip codes, so zip codes have 5 values. It got treated as a number. So it's got 7 characters because there's a dot and a 0 next to it. But we can do a value count just to confirm that the value of 3 is really just the characters NaN. And so we can also know that there's no leading zeros in this zip code value. And that also I know is New York City, all of the zip codes do begin with the number 1. So that does make sense. And then we can use that information to break down crashes by zip code level. So you can see this is how the zip code is stored. I really only need the left-hand bit of this information. And so we can look at our zip codes and look at the counts of incidents and do a very descriptive summary set of summary statistics of it. You can see that the 75th percentile has about 38 incidences. We can then plot instances by zip code. This doesn't make a lot of sense because there's so many of them. And so what we can do is we can subset, for example, only give me where the count is greater than 50, and then make it so that like I only actually see the zip code as a 5-digit string, and then we can replot the value, and you can see 11207, which I don't know where that is, does have the most amount of incidences. And so that is my very quick, brief overview of the analysis that Sam and Josh are going to replicate.
Thank you so much for doing that. Are there any questions? I'm looking in the chat. If there are any, feel free to put them there. And if not, then I have one question. Well, are there easy ways in Python to be able to do like include like geography, like mapping visualizations? Are there packages that are sort of standard for that, or is that something that?
So there are. The one that I know of is one called GeoPandas, so like geography
Okay.
stuff or pandas. So like
Yeah.
that is the big one. There are I think there's like a couple of geo-based things coming out of the Apache Arrow project as well. So that is another thing that's sort of like picking up as well. So yeah, GeoPandas is the first one that comes to mind. I am just really bad at dealing with anything to do with a map.
Oh yeah, I agree. I also have trouble sometimes once we are starting to actually plot things in like actual space. Um, Awesome. Well, I don't see any, I guess I have one other small question. So you mentioned at the beginning that you sometimes use Quarto because you kind of jump between languages, or that was do you, if you were to do this analysis, like if you were to sort of pick the pieces that were optional to do, like if you weren't asked to just do it all in Python, are there parts that you would have done in a different language, or like, do you have preferences for if you're trying to solve a certain type of problem, you usually do it in one versus the other?
So the way I do it, would have done it is all of the stat stuff. I probably would have done it in R, because like for me, I don't have to think about what is going on with this model. Why is it regularizing without me knowing? Um, the plotting bit, I am very good at R's ggplot2 library for plotting. So a lot of the plots I would probably end up doing it in R just because plot9 isn't 100% one-to-one with ggplot2 yet. So there's probably going to hit some wall where if I need a publication ready figure, I would do that in R. But if it was for me in this like really quick first pass analysis, this is fine, right? Like the fact that like I don't have a title, like I know what this means if I'm just looking at it myself. A lot of the other data analysis, like just this code stuff, this really for me just ends up being like who gave me this data set, who am I going to end up working with the most. I have that luxury where I can do that, so that just ends up being that type of question. If it does end up being a very, very big data set that exists on like a distributed cluster, that's when I personally would start staying in the Python world, just because there are tools like Dask that sort of give me the same code and same API as pandas, but I get to work on it as a like out of memory cluster or something like that. So that just ends up being some of the differences that I would do.
Nice. There's one other question that's sort of along those same lines that just came up in the chat. Basically, what's a data science task that is easiest or easier to do in Python versus R? So sort of along the same lines, but is there some data science?
I don't know if there's like a particular data science task. What I do like about Python is that like you can leverage like the rest of the language as a general programming language. So like this is sort of like the interesting thing is like if you learn R and you learn tidyverse, you actually tidyverse is so complete as a domain specific language that like you can get through so much data processing without actually learning like how to write your own function. It like gives you so much for free. Um, so that means that like down your tidyverse learning path, like you eventually have to learn how to program like in base R. Like you're gonna have to learn base R things. Python sort of, for better or for worse, doesn't really give you pandas doesn't give you that much for free. And so like to learn pandas, you kind of have to pick up some of the base programming bits along the way. But sometimes that does make it easier for you to um, create create analysis where you leverage like things outside of language. So like computations related stuff only exist in Python, but you can set up like experiments and how your computation happens and like using loops and all of that stuff. Those are things that you typically don't really see as much in the R world, but it becomes more of a thing in Python world. So and oh yeah, and natural language processing, yes, there are a lot of Spacey is the big language natural language processing library in Python. And I would say like that's probably a big one. I want to say like a lot of the computer vision stuff, so much of like PyTorch is already ported to R. So that's not really like that much of an issue anymore. I think which one? Like TensorFlow? It was either TensorFlow or PyTorch. Like it was literally when it was ported to R, like it was just calling the Python functions using reticulate. So like so a lot of the fun things about the R and Python ecosystem is like one literally just borrows from the other, right? Like pandas existed because data frames existed in R, and then things like what comes to mind, like the glue package exists because Python created f strings, and so like it is kind of funny how like both languages end up just copying each
Borrowing
other
from
for
each
better
other,
or for
yeah.
worse. Yeah. So it does go to like this other question that's been coming up, like what is the best language to learn? It really just becomes like who are you working with, who do you want to work for, because like fundamentally, if you understand like the data literacy bit, like how do you transform data, then all you need to do is think about those steps, and then it becomes like, how do I like pivot data in R or pivot data in Python? And then a lot of that is, then you're just looking at the syntax of code differences, but you don't have to worry about how to think about your data.
We have one more question and then we'll switch to our next presenter. So David asks, how can you comment on pandas versus polars?
Okay, so polars is really cool. It's written in Rust, and it can actually, so polars and ibis are data frame, pandas data frame alternatives that try to interact with your data frame as if it was a SQL table. So it will connect to databases and also like a regular data frame object. Polars is and ibis as well is what it does lazy computation. So like the code doesn't actually execute until you write the whole expression and ask for a result back. And so there are certain things in polars that can actually run pandas code faster than pandas itself, because it can optimize the pandas code for you. The other thing that I like about polars, and is something that I'm looking into as I'm trying to teach data science and Python in general, is that polars does not have this multi-index. I just call it shenanigans, but other people will get offended if I say it that way. But it doesn't have a multi-index, for better or for worse. And that just makes it so, like, for me as an educator, it's just one layer of things I don't have to teach, because the multi-index does show up unexpectedly in pandas a lot. So that's mainly, like, there are speed benefits, but it's also very different. The API is also very different. So it is learning a different way of coding if you do go down the polars or ibis route.
Great. Well, thank you so much. This was very helpful. As a non-Python user, I always love to see how to do these types of things in another language. So thank you for doing that.